Hello everyone. Today's class about multi-vibrator circuits. So during wave generator, multivibrators are widely used in electronic circuits. Wave shaping circuits are the electronic circuits which produce the desired shape as the output. So the multivibrator circuit is nothing but a switching circuit. It generates non-sinusoidal waves such as square waves, rectangular waves, and sawtooth waves, etc. Multivibrators are used as frequency generators, frequency dividers, and generators of time delay, and also as memory elements in computer, etc. According to the definition, a multivibrator is a two-stage resistance coupled amplifier with positive feedback from the output of one amplifier to the input of the other amplifier. So that means when two transistors are connected in feedback, so that one controls the state of the other, hence the on and off state of the whole circuits and the time period for which transistors are driven into saturation or cut off are controlled by the conditions of the circuits. When showing in this block diagram of multivibrators, it has two stages. That what he said. One stage for Q1 or transistor 1, the other or second stage is for Q2 or transistor 2. Then both of them are connected in the feedback state. So there are two possible states of a multivibrator. In first stage, the transistor Q1 turn on while the transistor Q2 turn off. In second stage, the transistor Q1 turn off while the transistor Q2 turn on. Thus, two states are interchanged for certain time period depending upon the circuit conditions. So, according or depending on the manner or the circuit in which the two states are interchanged, the multivibrator can be classified into three types: astable multivibrator, monostable multivibrator, and bistable multivibrator. So during astable multivibrator, no input control, thus the circuit only needs applied source. So our output is astable, unstable, that is off on in the output signal. During monostable multivibrator, one is stable and the other is unstable. So in the output, that is stable state, to change to unstable when pressing or clicking the triggering one, that we can call it one shot. So that unstable state change to that stable state change to unstable status. But in bistable multivibrator, in both of them are stable states. So if you need low T1 you can trigger, if you need high T2 trigger, and vice versa. So let's see one by one the principal operation of each types of multi-vibrator. During astable multivibrator, an astable is such circuit that it automatically switches between the two states continuously without the application of any external pulse for its operation. As this produces a continuous square wave output, it is called a free running multivibrator. The DC power source is common requirement for astable multivibrator circuit. So an astable multivibrator has no stable state. Once the multivibrator is on, it just changes its state on its own after a certain time period, which is determined by the RC time constant. A DC power supply or VCC is given to the circuit for its operation. Then, after the gating of applied source by itself, on off two states, that is Q1 and Q2. So let's see how they construct that astable multivibrator. When two transistors named Q1 and Q2 are connected in feedback to one another, the collector of transistor Q1 is connected to the base of transistor Q2 through the capacitor C1 and vice versa. The emitter of both the transistors are connected to the ground, the collector load resistor R1 and R4, and the biasing resistor R2 and R3 are equal values. The capacitor C1 and C2 are equal values. So let's show him when resistors, four resistors, two of them biasing also applied, and also a capacitor, that is R1, R2, R3, R4. Both of them are in parallel connected. Also we can give VCC. Let's say example 10 volt. This is C1, C2. Then from this R4 biasing to the collector of, let's say example this one is Q2. This is collector, emitter, and the base comes from the second type of transistor. This is base, and again from this one base, collector, emitter, and the emitter becomes to the ground. This is a astable multivibrator. Astable multivibrator. Astable multivibrator. So when he applied a voltage source to the circuit, that one of them, let's say example Q1, this one, this is Q2, then one of the transistors, it becomes turn on according to their manufacturing base, because collector current equal to beta of base current. So according to that beta, one of them is first turn on. So let's say this one is on state that reached saturation region. That means in the base becomes 0.7 volt, but in this base that comes 0 volt. After sometimes this becomes our output of this one, for let's say example this becomes B, this becomes A terminal. From B terminal we get high. After few time this capacitor, becomes charged, then that charging it gives to the base of Q2. This base or Q2 or transistor 2, it reaches to 0.6. That means this Q2 becomes saturation. That saturation means both are closed. Then the current becomes move sort of to this one. So that means Q1 becomes 0. 0 volt. That is off state. This becomes as the first time off and now on state. So by this principle, by charging discharging of this capacitor or RC timing, we can get the square wave, or let's out our output from this one. We can get low, high, low, high. So how to determine our question? How to determine the period of this equation from this one to this one full period? That T1 and also T2, we have two periods. That means when you say T1, that Q1 on state, Q2 off state. When you say T2, Q2 on state, Q1 off state. So T1 means, according to the past circuit, 0.69 R2 C1. The same T2 becomes T2 that Q2 on state, Q1 off state. That is the same 0.69 R3 C2. But don't forget, all components are the same value. That means C1 and C2 are the same value. And R1, R2, R3, R4 are also the same value. At the same value, we can get this one. So our period becomes T1 plus T2. So that means 0.69 R2 RC1 and 0.6 RC R3. That lets R2 equal to R3. That becomes R. Again, C1 equal to C2. That becomes C. So 0.69 RC to C1 plus 0.69 R3 C2. So approximately this becomes 1.4 of RC, because R2, R3 are the same, C1 and C2 are the same, so we can call it or replace by R, can replace by C. So this is the period of our astable multiplier. So, and also we can get our frequency V is equal to 1 over period. So we can calculate it a frequency. So according what I show is the circuits, that is R1, R2, R3, R4 are in parallel connected with the VCC, C1 through R1 and R2 in the between R1 and R2, C2 between R3 and R4. Our output from A terminal, we can get also from B terminals. So transistor Q1, the base comes from the collector of Q2. Transistor T2, Q2, the base becomes from the collector of Q1. So by this principle, when VCC is applied, the collector current of transistor increase as the collector current depend upon the base current IC beta times base current. As no transistor characters are like according to their manufacturing, one of the two transistors, say Q1, its collector current increase and just conductors. The collector of Q1 is applied to the base of Q2 through C1. This connection lets the increased negative voltage as the collector of Q1 to get applied as the base of Q2, and its collector current decreases. This continuous action makes the collector current of Q2 to decrease further. This current, when applied to the base of Q1, makes it more negative, and with the cumulative action of Q1 gets into saturation and Q2 to cut off. Thus the output voltage of Q1 will be VCC saturation and Q2 will be equal to VCC. Then the capacitor C1 charges through R1, and when the voltage across C1 reaches 0.7 volt, this is enough to turn the transistor Q2 to saturation. As this voltage is applied to the base of Q2, it gets into saturation, decreasing its collector current. This reduction of voltage at point A is applied to the base of transistor Q1 through C2, which makes the Q1 reverse bias. A trace of this action turn the transistor Q1 to cut off the transistor Q2 saturation. Now point B has the potential VCC, the capacitor charges through R2. The voltage across this capacitor when gets to 0.7 turn on the transistor Q1 to the saturation. So by this principle we can get a square wave generator. Hence the output voltage and the output waveform are formed by the alternate switching of the transistor Q1 and Q2. The time period of this on-off state depends upon the value of biasing resistor and capacitors used. That means on the RC value used, as both transistors are operated alternately, the output is square wave with the peak amplitude of VCC. So our output waveform as a collector Q1 and Q2 are shown in this picture. What I show you. So when Q1 on, Q2 off. So from the terminal A, that is low. When Q1 off, Q2 on, that becomes high, low. So there's the same preset in other side, in the P side also, opposite of this one. To understand this one, let's show you by simulation. So this simulation in meltism, that is astable multivibrator, astable multivibrators. For example, to understand, let's from that in the circuit, the emitter terminal directly to the ground. But let's see connect with LED. Then when you run this circuit, let's play or run this circuit, look the LEDs. Once on, off, on, off, on, off, on, off, on, off. That means high, low, high, low, high, low. That LED light becomes during high when you can get a source that's on. When Q2 off state becomes off. So by this principle, that astable multivibrator that becomes without any external triggering, we get a square wave signal. A square wave signal. So simply astable multivibrator, it looks like this one: high, low, high, low, high, low. So the frequency of the oscillation, what I show you, the on-time period of transistor Q1 or the off-time transistor Q2 is given by T1 becomes 0.69 R2 C1. Similarly, the off-time of transistor Q1 or on-time transistor Q2 is given by T2 0.6 R3 C2. Hence, the total time period of the square wave, that is period, becomes T1 plus T2. That let's see. Example R2, R3, R, that R, C1 is R equal, it becomes C, the frequency of square wave will becomes 1 over period. So this is how to get the frequency of astable multivibrator. That's 1 over period, that R period 1.4, that becomes 0.7 of RC. So let's see what are the advantages of this astable multivibrator. Advantage of using an astable multivibrator are: no external triggering required. Circuit design is simple, inexpensive, can function continuously. So by this means that advantages when comparing with another type of multivibrators. And the disadvantage or the drawback of using astable multivibrator are: energy absorption is more within the circuit. Output signal is of low energy. Duty cycle less than or equal to 50% cannot be achieved. So by the 3 points are more drawback when you compare it with another more stable. So where they apply the application of astable multivibrator. Astable multivibrator are used in many applications such as amateur radio equipment, Morse code generators, timer circuits, analog circuits, and TV systems. We can use astable multivibrators. Now the next, let's see about monostable multivibrator. So and also how monostable multivibrator is worked.